Hello, this lecture, this video recording is focused on getting to know your data. Okay, so this is a important step, and it's kind of sometimes funny to think about, but the more time you spend with your data, the better you will know your data. And so ultimately we want to get to the point where we understand what our data is telling us, but we need to spend some time with it to be able to move forward. So during the examination process, when you're thinking about the data that you're going to work on and the data set that you just received, you want to do a series of steps. And so they may include just preliminarily like observing the data, looking at the actual numbers that you have, looking at the variables that you have and understanding where the variables came from. And then we're also going to do a graphical examination, and then other steps that are not covered here in this video deal with missing numbers, outliers, and confirming assumptions of the data that will need to be confirmed in order to do multivariate data analysis. So first we're going to start thinking about having a preliminary understanding of our data. And again, this is getting to know where and how and why the data was collected and what you should expect to see in the data. So be very conscientious of the questions you should ask when you're looking at your data for the first time. Do you have the actual survey instrument or the interview form? What do the questions look like? How were the questions asked? Who compiled the data? Why was the data compiled originally? So if you're using secondary data, for instance, that's a big question. What limitations does the data have? Do you know what the collection protocol was? In other words, what steps were used in order to collect the data, and were those steps done properly? Where are the sources of potential non-sampling error? So were there potential mistakes made in the data collection process? Where will you typically see mistakes in the data if they exist? Kind of try to troubleshoot and think about like how strong the data is, how reliable, how valid the data is here, and why it might not be a perfect data set. So there's no such thing as a perfect data set, and you want to think about why there may be error in your data that you have now. Okay, so these are the typical things that we want to think about. We also want to now think about what type of data, whether you're going to have like non-metric or metric variables, whether they'll be interval or ratio or ordinal or nominal types of data. You want to think about the scale ranges that you'll have. And so you just want to look at the instrument that was used to collect your data and just take time to think about how the data should look before you even think of even open up the data set maybe to confirm that. So again, then as we do this, we want to think about like the structure of the data. Think about is the data in Excel? Is it in SPSS? Is it in columns? How many columns do you have? How many rows do you have? Do the rows represent the respondents? They probably do. Do you have dummy variables? Do you have like odd things like do you have dates in your data that need to be converted into some other type of a number? Do you have any type of qualitative data or open-end response questions? Those are all things that you want to like just know and be able to expect in your data set. You want to be conscientious about how your data is stored. You may consider how safe your data is, if it could be hacked, if it could have personal identifiers in it that you want to keep private or confidential. So there's some ethical issues that you want to kind of think about at this point too, in terms of how the data is being handled, what type of software will you use. We have something called a data code book, which we'll mention here in just a minute, and you want to know if you have one of those. Again, you want to review why the data was collected, where it came from, what each variable represents. And you can also think about now how you envision the data being analyzed. Like, how do you think the data will be, what type of multivariate technique, for instance, you might use, and so on. So it's never too early to start thinking about that, even though we're just doing a preliminary scan of what we see the data to be now. Okay, so I mentioned coding in the data codebook. So basically what we need to do is we need to understand what the measures mean and what the data means. It's in each cell in each column of your data set. This is particularly important when you have variables like gender or non-metric types of data or categorical data. So like, let's say you had a question that asked people, what social media do you use? Do you use Facebook, Pinterest, Snapchat, or LinkedIn? So I've got four different ones. In your data set, a number 1 might represent Facebook, a number 2 might represent Pinterest, a number 3 might be Snapchat, and a number 4 might be LinkedIn. So in your data set, you're just going to have 1, 2, 3, or 4. You're just going to have a series of numbers, but you don't know what the 3 stands for or the 2 stands for without some type of a code or a coding report of some type. So the coding process takes the data and puts it into numeric form, and the numbers represent something. So we want to be able to structure this in a way where it makes sense and we kind of know what it is. And then we want to create what we call a data code book so that we are able to, it translates the numbers that are in the column for the measures or meanings that it has in the actual data set. Okay, so we use data code books. It's oftentimes it can be a hard copy, an actual copy of the survey with the data names and with the actual codes in it. That's something that I actually like to do. I always like to keep a hard copy of the survey with the codes on the survey itself so that I could take the survey, I can match it up to the spreadsheet and know exactly what I'm dealing with. Okay, so the last part is the data code book would include all of the different options or items that could possibly be used in the survey itself. Okay, so here's a little bit of data. This is the first column, do you consider yourself a Republican, Democrat, or neither? And we have 1, 2s, and 3s in that particular column. So we have 1, 2s, and 3s. Well, I don't know what a 1 is, a 3 is, or a 2. Here's gender, 2s and 1s. I don't know whether 1 is female or 1 is male. So there's a case where I need the codes, the code book, to tell me what those stand for. Okay, education. I don't know what a 6 is, a 5. I don't know what a 3 is. Age, I assume this is age in years, but again, that would be an assumption. Income level, these different scales here, like I don't know what the scale range is. Is this on a scale, like there's an 8 here. Is this on a scale of 1 to 10, 1 to 9, 1 to 8? What is the scale here? I don't know what those scales are just looking at the data set. So I need the survey or I need a data code book to tell me exactly what I'm looking at so that I can understand what this is. So as a preliminary scan of your data, get to know where the data came from, get a hold of the actual survey, make sure you have a data code book, and make sure it's all in a safe place. Okay, so then as we move forward, we want to begin to do a descriptive analysis of the data that we have. So when we do a descriptive analysis, what we want to do is describe the variables and maybe do some basic averaging of the data to understand what a typical respondent is like from the sample that we sampled from. So we can summarize the data where we want to describe the data using some statistical measures, which will be like our mean, median, mode, standard deviation, range, variance, minimum, maximum, stuff like that. We want to be able to apply understandable conceptualizations. So in other words, we want to be able to take our data and maybe do some simple graphing to illustrate the data, like in histograms or frequency charts or something like that. We want to be able to let others know kind of the patterns and communicate maybe what we see in the data. And in this stage here, we're not doing hardcore analysis. What we're doing is descriptive research. So this is not causal research, this is descriptive research, and it may even be exploratory research that we're doing when we're getting a preliminary understanding of what the data is all about. So that's kind of, again, we're getting to know our data. That's what we're doing here. So again, we can go back and understand that if we're using nominal and ordinal data, we want to do a count of a frequency and maybe do like a bar chart of some type illustrating maybe the degree to which one choice was made over another. If we're using interval data or ratio data, then we can do like means, median, modes. We can do a lot more arithmetic means. We can do standard deviations and variance in that case. And so for each variable, what we should do is we should do this. We should calculate the mean. We should look at the range. We should look at the standard deviations. And these things will actually help us because they will help us spot problems in our data that we need to be aware of. So this will actually help us identify missing data, outliers, and then it will help us identify observations maybe that are just out of place. Okay, as we do this. Another feature or moment, if you will, aside from means and dispersion variables, we have kurtosis, which would suggest the peakedness or pointiness of the distribution. So something that is like extremely flat, like platykurtotic, that may be problematic when we're doing regression because it's not normally distributed, and also leptokurtotic data, which is really peaked, is a problem as well. The other issue that we deal with is skewness. So like if one part of the distribution is more heavily weighted than another, then that's an issue that we want to be concerned with. So measures of central tendency, that's one moment. Dispersion, which would be like standard deviation and the variance and range, that would be a second moment. Kurtosis would be the third moment. And then skewness would be the fourth moment when we're looking to take summary statistics of our individual variables. And again, we want to do this for all of our variables. Every variable that we have, we want to be able to describe our data. And so we need to do this as a step in the research process. Beyond this, we can do things like we can create charts that help us understand what our variables look like. And so if we reported our 4 moments and then we also created a histogram or some other type of chart, then that would help us also graphically describe our data. So here's an example with a average of 100 and a standard deviation of 15. Okay, and this is some variable that we have and the measurement of that variable, and each one of these bars indicates samples that have been drawn, and we can kind of see a general pattern of normalcy, and we could kind of illustrate here. We could also have an actual calculation for kurtosis and for skewness, right? and that would tell us also how the data looked, and it would be illustrated in a histogram, and that would be a nice way to correspond the picture with the actual summary statistics that we show. If we have more than one variable, sometimes that we want to look at the relationship, at least in a preliminary sense. We look at the relationship that two variables may have together. So we can use scatter plots, and using, again, we have two variables here. So this shows kind of a general relationship of two variables. Here, when these variables are plotted together, so each little dot here is an observation, and like a respondent gave an answer for X and they gave an answer for Y, and this respondent was right here with it. We can see that the respondents are in general tightly formed and going up, so that's probably a fairly high correlation, and it's going up, so it's positive. Here it's going down, and again, it's fairly tight in terms of the dispersion, so there's not a lot of variability here. So the variance is fairly low, which results in a fairly high correlation. And then this is an illustration where there's really no seemingly observable relationship between these two variables. So this is a scatter plot, and again, it's a general depiction of the of what's available to, or of two variables that are there that we can show. Another graphical examination or description is a bivariate profiling matrix, which is extremely helpful. And this shows in one grid here, it shows three very important things when you have two or more variables. You have, first of all, in the diagonal, each variable's histogram. So this is the histogram for X6. And you can see this one here is fairly flat. It doesn't really look very normally distributed, so that may be a problem. We have this variable here, which again, this one may actually be a little skewed, but this is X7's histogram, and then we have X8's histogram here, and then we have 9, and we have, or 12, and then we have 13. So we have a variety of histograms, one for each variable. So we have 5 histograms, 5 variables. Then we have our scatter plots. Like this data looks pretty like it's related. This one may be going down like this a little bit. This one again may be going up. Others here may not have any relationship. It's kind of tough to tell. So we have our scatter plots, and then on the top of the matrix, we have the correlations between the two variables. So we have this is, I guess it may be going down a little bit, and so it's negatively 1.37. That's the R, the correlation. We have fairly low correlation here. Here we have a big correlation, and that would be this one, this box here. We have another fairly strong correlation here that's negative, so we've got one going down there. We've got a positive 0.265, so that could be significant going up here. And so again, you have an illustration here of multiple variables that are sort of happening together. This is, again, a very powerful way to describe and just illustrate and show your data. We haven't really analyzed data a lot, but this is descriptive research. This is describing the variables. Okay, and here's another example of a graphical examination, which would be a box plot. The box plot has 3 or 4 pieces here. First of all, it has the quartile ranges. So we have the range of responses within the first, the second and the third, and then the fourth quartile. So the second and the third quartile should be in the middle, with the mean also illustrated here with this line. And then we have these confidence ranges that would be in here, and then we have some weird outliers that are here. These would be individuals who fall anywhere from 1.5 to 3 times outside the average or outside the expected range here. So these would be probably based on your standard deviations. And it's really a graphical illustration of your variables. So in this particular variable, we have product quality, but then we have 3 different levels of product quality, and then we have consumers' responses within these categories. Okay, so again, this is going to be a box plot. So we have the box in the middle, and then we have whiskers that are going on here. So this helps us identify again where the median is. So this is actually the median. The middle 50% responders, which is the box here, and then we have the whiskers, and then we have outliers. So these outliers, again, they're going to be statistically individuals who are statistically outside of some type of range. It may be a standard deviation or 2 or 3. Sometimes it's set, depending on your software, to be like 1.5 standard deviations away from the center, or maybe 2 or 3 standard deviations. So it just kind of depends on your software in terms of how they will identify the graphical position. And this might be an observation that you take a closer look at, and you might decide to eliminate them because they fall too far outside of your acceptable range. Okay, so other ways to illustrate or describe our data then that move beyond the simple 4 moments. We have tabulating cross tabulations. So when we tabulate our responses, we're placing them into a table, and we're often just using that table to create some type of a frequency chart, or something that shows the frequency in which a response was made. Okay, cross tabulation then often shows, or we try to illustrate, how respondents answer to multiple questions. So if they answered one way to a question, how does that impact how they answer another question? And so we do this with group differences and things like that all the time. Chi-square is a statistical test for significance between differences between frequency distributions. So again, we do chi-square testing when we look at between groups, categorical variables like non-metric variables as they relate to the cross-tabulation tables. Okay, so and then we do ANOVAs as well. So ANOVAs relate to an analysis of variance test. Might be something that we do when we look at the mean difference between 2 groups to understand whether the mean difference is significant or not between one group and another group. Okay, so these are moving into more analysis as opposed to description, but you could still use cross tabulations, chi-squares, and ANOVAs. You could begin to start using those for descriptives as well. There's a crossover here between causal research and descriptive research, and these are some of the basic techniques that could be used to help move you further. And again, at this point, we're just trying to understand our data and just try to summarize it somewhat so we know what we're dealing with. So those help us do that as well.